and we provide support and support services on top of it. Brief description about us. These are a couple of companies that we have worked with, and we have a bunch of partnerships, prominent ones with Cloudera and Databricks, which got us involved into this, the whole Pig on Spark kind of initiative. I'm going to talk about Pig on Spark primarily, and then talk about the project above, which hopefully tackles a whole bunch of problems that Jonathan talked about just previously. Okay. So what steered us into Pig? So we had a whole bunch of customers which wanted to write very deep, rich pipelines, and they were just adopting Hadoop. And most of them were doing essentially MapReduce work, which is very surprising. It says 2014. Yeah, so essentially we help them kind of adopt Pig and essentially get used to writing pipelines. Primarily, if you look at kind of analyst environment, it's much more easier to start and bootstrap on top of Pig versus write MapReduce code. MapReduce code is not testable. This is like such a pain to actually manage, work, reuse. Like it's a real big headache. But again, like 2004, it was very good. But now 2014, 10 years, starting to age. So Pig was really, really useful. And ironically, one good thing for us as a separate development team versus an analyst team is that the analyst team kind of came up with recs that, okay, I need to do these transformations, these things. And we could provide them UDFs, which are like cleanly integrated, and they could just add this functionality on top of Pig and enhance their Pig library. It's actually quite surprising that like a Pig marketplace kind of never came up. It would be very interesting for people to leverage functionality on top of Pig. Like these guys had like a whole bunch of Pig UDFs and stuff like that, but it never came out in the open source community, which would have really made Pig a powerhouse to kind of leverage. There's a whole bunch of companies who are using Pig and enhancing its functionality with UDFs underneath, but the network kind of never came across. So it's really good. It's a whole bunch of rich operator libraries, things which are very, very hard to do in MapReduce. You need really smart people to write replicated joins on top of MapReduce, but like Pig just made it simple, easy, right? And that's sort of the war of the Hadoop system has been since the very beginning, that developers create really powerful functionality, and at the end of the day, the main consumer of Hadoop is always going to be an analyst who's going to generate a report. And kind of systems have tried to kind of tackle that in different ways. Hive came along almost the same time as Pig, which essentially allowed people to write SQL queries, and Pig was also quite great. It allowed analysts to write SQL-like language, so to speak. And so I think that's something that's going to keep going on. Like you'd want your analysts to be smart about data, and you'd want your developers to have a platform that is extendable, so that your analysts can do more and more stuff without writing code. And so that fragmentation is happening, and I think it's going to keep happening. And Pig was one of the great steps, first steps towards it in terms of exploring. It's really, really powerful ETL. So the couple of things that Jonathan talked about, right? Functional programming. So Pig, in a way, in the very beginning of days, were built on top of those templates. So if you look at a Pig pipeline, right? So you do load, you do some transformations, and you do store, right? So until Pig really knows what all you want to do with your data, it doesn't actually execute the pipeline, which is quite great, right? It's lazy. It's one of the best things about Pig. So Pig knows exactly what all you want in the entire pipeline, and that's why it's able to optimize your entire pipeline and generate fewest MapReduce jobs than needed, right? And generate only those intermediate data states which are required, and all the good stuff out of laziness and stuff like that. And the second thing is it was really designed to be pluggable, like from the day one, right? So there was local and MapReduce mode. So and they did a lot of work to extend it further to add other execution engines, but it was designed to be pluggable because they understood that the value of the language is in terms of expressibility, and the power of the platform comes from what it leverages underneath, right? So tomorrow you come up with super powerful XYZ kind of system, and then you can just plug Pig into it, and all your existing Pig code would just start to run so much faster, right? So that's sort of what happened with Spark, but so quite great, right? So all these things made it really good for us to use Pig and kind of help our customers adopt. And around that time, we came across Spark, which is amazing, right? So Spark was so much more powerful than MapReduce, right? So much more powerful. And in a way, that there was like so much problems of MapReduce that they solved. So like types, right? MapReduce had types, but it was types across map and reduce. right? And then what happens when you have the subsequent map job, right? Like there's no way to know that the reduced output of your previous map job is going to actually generate the same time as your next map job is going to consume, right? So chaining map reduced jobs, you lose types, everything is gone, right? You lost. While cascading used to do it pretty well, Spark kind of took it to the next level in terms of being completely functional in its structure and stuff. The second thing that was very interesting about Spark is that Spark, Pig had higher level operators, right? So you filter data and you do a whole bunch of more complex stuff, like you group by data, you filter data and stuff like that. The interesting thing about Spark is they broke those operator structures down to the bare minimum, right? So they support mapping, they support reducing, they support folding. So their operator structures are much lower level, which again make it very good for developers, but make it hard for analysts, right? If I ask an analyst what is fold, I don't know what is fold, right? So, their operator structures are simpler, but which also makes it pretty powerful in terms of expressibility. Now, if you need to do a filter on a group by, you can express it at a lower level, and then you can reuse that code in a whole bunch of new ways and stuff like that, right? So obviously, like it's a line that you're crossing, right? So at a certain point, you are very expressible and very low level, and which is very good. But then at some point, you want to actually be at a very higher level and just talk about the data wrangling I want to do, and not really talk about how do you want to do the data wrangling. So Spark is, I believe, at a different balance than where Pig is, but it's really, really powerful. The other thing is it's really debuggable, it's nice, it has types, and it has transformations, it optimizes those transformations. It's really, really nice in terms of exploring it at a local level and then deploying it at a global level. It scales out very nicely and stuff like that. Efficient execution, right? So there's a lot of discussion around how it's efficient, and then you can obviously do other stuff which is almost as efficient and stuff like that. But there are two things about Spark which make it really, really interesting in terms of efficient execution. So one thing is common with Pig, actually, surprisingly. It's lazy. So Spark is as lazy as Pig. So Spark also knows exactly what you want to do with the entire transformation before it actually does the transformation. The same thing that is true with Pig, right? So it knows the whole thing, what you want to do, right? So theoretically, it can optimize it as best as you can, right? So because it knows exactly what you want to do. So that's part of the reason it's really, really efficient in terms of execution, just like Pig was very, very efficient in generating map reduce jobs. And the second reason it's really, really efficient is basically because it's a JVM-based language, and basically it manages memory well and stuff like that. There are bad sides of it as well in terms of heap memory issues and stuff like that. One good thing which is relevant to a lot of customers is universally distributed now. It's part of Hortonworks, it's part of Cloudera, MapR, and it's like a whole bunch of distributions. So if you have a Hadoop distro in your system, you probably have Spark on it, like sooner rather than later. So which made it really, really interesting, and the community is really good. They're really, really helpful. They're really, really collaborative. You'll see I'm part of a whole bunch of open source systems, but the amount of activity and kind of help that I've seen in the Spark ecosystem is like bar none. Like I've not seen anything better. So so good things about community, really powerful API, efficient execution, so all the good stuff of Spark, right? So what do you do, right? So probably I should first talk about how we came to this. So a whole bunch of customers had a whole bunch of Pig scripts, and they said, okay, let's figure out how to get it on top of Spark. And we said, okay, so we can translate each of your jobs, or we can basically migrate Pig on top of Spark, right? It sounded like a crazy idea at that time, but we saw, okay, so we saw actually work done by Twitter folks around some of the migrations. It was terribly broken, no offense, and but it looked like a good step, right? So the structure was there, but it was broken and it needed fixing, but it sounded pretty good. So we took the whole bunch of customer scripts and saw, okay, there's some issues around it, let's fix those issues, and that's how the journey sort of got started, right? So the good thing about Pig and Spark, as I said, right, both are lazy, both have operators, so there is some harmony in what they're representing. We just need to figure out how to actually map the harmony together, right? So that's how we sort of came up to the operator mapping sheet, right? So we saw, okay, so there's a whole bunch of operators that we have in Pig, and there's similar functionality that we have in Spark, and like let's see if we can map everything together. And that's how sort of the activity started, right? So you've got filter. Filter can be represented as a map of a filter function, right? That's what actually pig does internally anyways, so it doesn't matter, right? So you've got group by, so okay, I probably need to sort the data and then probably do some group bys on top of it and stuff like that, and produce the outputs and manage the tupular structure and stuff like that. So that's how sort of the activity got started, where we migrated very simple functionality in the very beginning and then added more and more functionality. This does not capture like UDFs, right? So UDFs were a bit of a challenge to work across, and definitely the pig code base does not help. But yeah, it's really hard to figure out what's going wrong, especially in the distributed state. You'll see stuff that's working in the local but not really working in the distributed state. The threads which are managing UDF contexts and like a whole bunch of problems. But enough time, energy, and sweat and blood, and then we got it working. So so I'll probably so this is a basic stuff like how it actually works right now. It's so pig. So initially, when you write a pig script, it translates it into something called a logical plan, like logically what the user is trying to do, right? At that point, it translates that logical plan to a physical plan, like how will it actually execute, right? So what all actions will I need to do on the operator and get it running and stuff like that. So and from the physical plan, it generates map reduce jobs and so on and so forth. So we tapped into the middle of it. We used a whole bunch of MR stuff right out of the pig. So we generated map reduce operators out of the system. So it's a whole plan of map reduce operators. So in map reduce, you would do this, and this, right? So that's great. Then what we did is that we just overrode them with Spark operators. So wherever the chain of map reduce operators were there, we recursively translated up the tree and replaced all the operators with Spark operators, which were written natively in Spark. And that's it. And then we passed the whole engine to Spark execution engine. Again, a whole bunch of stuff was really handy that both of them are lazy. Both of them have operators. So it's just pretty simple and easy to translate operators within each other. One big problem was definitely the Java and Scala thing. Spark is natively written in Scala. They have a Java API on top. It remains pretty updated compared to Scala API. But what I've seen, as with like any leaky abstraction, you end up kind of going down to Scala level very, very quickly and stuff like that. So it's useful, gets your work done, but eventually just like a lot more comfortable saying, okay, let's just go to Scala and just get it done. But we knew that pig community would not be that happy with kind of Scala code base inside the pig code base and managing SBT, and already they were doing and to Maven migration and all those things were happening. So we used the Java interface as well, but kind of tapped in a whole bunch of Scala APIs from the Java interface, which again I don't really like as an engineer, as an honest engineer, but that's okay. So so eventually that's some of the current flow. So what are the issues around this? So we managed to pass 100% A2E of pig, which is basically the end-to-end test use cases of pig. But we are working constantly in terms of scale, because pig, as you know, is basically an ETL language, and ETL is talking of terabyte scale. So you need to really make sure that your Spark code is efficient so that you can actually manage to run at that scale. Again, it's much harder in pig because we need to pass a whole bunch of configuration parameters in order to make sure that it scales out really well. But pig doesn't make it really easy to kind of perform that. So an example of that would be that if you are performing a whole bunch of maps, simple maps operations, right? Spark would expect you to kind of repartition your data so that every core can work on top of each piece of data independently, but there's no like repartitioning concept in pig, right? So it becomes really hard to kind of pass on this information to from pig to Spark and stuff like that. So performance is definitely a concern. So we've been able to get close to about 10x performance on disk, but there's no real way to actually leverage the in-memory information of Spark very nicely. So we're still working on how to actually make that happen, especially as you kind of generate intermediate data. You really would like to kind of cache it in memory if it's going to be used by multiple people down the pipeline, right? So you want to kind of leverage that. So that's performance that's definitely a lot more important. We are working on adding Spark-specific operators. So like I said, caching is really relevant. So a person who's writing the code would really love to kind of cache the data at a certain point and probably use it further down the pipeline and stuff like that. So definitely working on adding more Spark-specific operators. We are working on pig on Spark unit test case because that's really important for it to merge back into the main trunk. That's kind of a criteria. So we're working on ensuring that the unit test cases work and like the output and input match, and then you're not suddenly seeing a sales drop when you so you're operating 100x faster on so many less users. You probably don't want to do that. And there's some specific joins and rank operations which are not working, so we are working on towards fixing those. Surprising that E2E didn't catch these things. So how you can contribute, there's an umbrella Jira that you can see. It contains a whole list of issues which are right now present in Pig. It would be really useful for you to kind of check out the code in the branch and just see the issues, probably try to fix it now that I've given you like a lot more information about it. The repository is a bit old in Apache because there's a whole bunch of conflict in terms of what all we can change in the Pig code base in order to get the Spark thing in. So you can obviously leverage that code base, or you can leverage this code base. Both are open source, Apache license, and we have a whole bunch of issues present in the issues list. We're trying to migrate all of them to Jira, but you can get some sense of where the project is. So what else are we working on? So I like to talk about Sigma Stream, which is basically kind of talks about almost all the things that Jonathan said. It's a DSL, it's a Scala DSL, it's a type-based language primarily designed for streaming, but it also does ETL operations on top of static data. It's again open source, that present in Apache license, present in our repo. Let me know if you want to try it out. It's very, very nice in terms of operators. We serve all the operators that Pig already provides, and we are actively adding more and more operators. Since it's a Scala DSL, you can basically enhance it and add more data into it. The key focus that we've had is to have a REPL, kind of very same to like what Pig has. So it's pretty much similar to what the Pig syntax is. We've tried to kind of maintain parity between them, and it manages a whole bunch of streaming use cases. Again, it leverages Spark as the execution engine underneath. The other thing we're working on is CloudFlux, which is more cloud deployment and blueprint system. So if you have sort of a certain structure of machines that you launch and deploy softwares on top of it, it's a cloud DSL. Again, it's a Scala DSL, which allows you to manage and deploy systems at scale. So you can test out the DSL with 1 or 2 machines, see if it's deploying properly in the dummy mode or in actual systems, and then the same DSL will basically scale your deployment to hundreds of machines. It scales. It has auto-scaling logic built in, especially if you can leverage Apache Helix or Apache Mesos. It has a programmatic interface. It's cloud agnostic. We leverage JCloud for that. We're providing it again under Apache license. And the key benefit of this system basically is that it leverages Spot instances very nicely in systems like Amazon. So we provide you to do programmatic logic in terms of auto scaling. So you can tap into your CPU usage, you can tap into your disk usage, memory usage, and basically scale your system up and down as you sort of need it. So these are 2 things that we are actively working on as a company. Happy to answer questions about that. We are in Strata P15, so if you're also in Strata, please give us a visit. We will showcase both of the tools to you. And that's basically us. Thank you. Thanks a lot.
Okay, so we have a little bit of time for questions. You guys want to ask questions?
I'll be the speaker. Don't be shy. I have a question. How much work has gone into the Pig on Spark project with your team already?
So we worked pretty hard on it for about 2 months. I don't know how much work Twitter already put in, but okay. So then in that case, I would say that 3 months of like about 2 folks, me and 1 more guy. That's it. So it's pretty easy. I would say that once we figured out the logic and the template, like I showed you one template, right, filter, then it was pretty easy to replicate it across other operators and sort of just get them working and stuff like that. That said, we still haven't written the unit test cases, so okay. I wouldn't say that it's completely done, but yeah, that's pretty much about it.
Are you close to getting it all the tests passed?
In terms of E2E, it passes, so I'm not really that adamant in terms of unit test cases to get it batched into trunk. We are using it with 2 of our customers already, so it's pretty much in a good state. There are certain issues like we need to migrate to Spark 1.0. It's right now on Spark 0.9. So that's one Jira that basically we are actively tracking. And there's definitely scaling issues that are coming up, which are much harder to test as a small company because like you need to actually set up and roll out hundreds of nodes and basically then test it at that scale and stuff like that. So that's something that we have not been exhaustively able to test out for all the operators, which we would like to. There are certain weird issues, so I'll talk about like, so in Pig what happens is that if you sort and then you put a limit, it does not generate a limit operator. It tries to kind of compress the two things down in sort itself. So in sort itself, it applies to limit. So you see issues like this suddenly come up, right? So there's some, like you said, right? That's state. You definitely don't want your limit operator to actually modify a sort operator, but you find issues like this, which you basically need to fix. It's surprising that there's no E2E around that again, but yeah. So there are edge cases and issues like that, and there are a bunch of operators we've been able to scale, especially because we worked with customers which use those operators. But we are actively looking for more customers and companies who leverage it and test it out and kind of reply to that, basically. Yeah.
How's the performance of the Pig on Spark ETL pipeline compared to like a Shark pipeline or a native Spark pipeline?
I would say that there's not much difference. So what happens is that, so I created a Spark pipeline, right? So Spark then further optimizes the pipeline internally anyways. So I created a bunch of operators in Spark, and then now Spark optimizes those operators further, right? So you rarely see a difference in terms of what Spark output is going to be versus what Pig on Spark output is going to be. That said, Spark is definitely a lot more configurable when you use native Spark interface versus when you use Pig interface. So you'll definitely see those differences, and that will sort of depend on how many parameters and stuff we built in to Pig on Spark to kind of tune the performance underneath. Plus, if you don't leverage Spark specific operations like repartitioning of data, like I said, and caching of data and stuff like that, you definitely lose a bunch of control out of the system. So, those are a couple of things which you definitely kind of would love to have as part of Pig on Spark, but you need to then figure out how those would translate to MapReduce and Thais and stuff like that, and all those things. So yeah, so I would say that implemented, it would be definitely smarter and better than writing a Spark code base yourself. But that said, a smarter person who can basically write an optimized Spark pipeline can obviously beat it in terms of implementation, no doubt. Okay.
Thank you, everyone.
Thanks a lot.